I'm George Crump, lead analyst with Storage Switzerland. Thank you for joining us today. This is another in our series of ongoing Chalk Talk videos on various subjects impacting the storage industry. Today we're going to focus on storage controllers. This subject has become recently a top read subject on our website. We have an article on our site called What is a Storage Controller that has grown through organic search, and so clearly it's something that people want a lot of information on. So let's talk about that. So first, let's talk about what a storage controller is and where it goes. So from a positioning standpoint, you can think of a storage controller basically as a computer that goes inside a storage array. Okay, and so usually a classic storage system has a dual controller system. So these are basically typically two CPU modules. They can be multi-core and things like that. And then there's a series of disk shelves that attach into that. The CPU does, or the controller does all kinds of different things. In the early days of RAID and things like that and external volumes, primarily what it did is some level of volume management and also typically RAID. RAID, as we've talked about, is a form of data protection of some sort to protect you in case of a drive failure. There's different RAID levels that most people are familiar with, RAID 5 and RAID 6 being probably the most popular nowadays. But this controller, and I think one of the reasons that this article has risen in popularity, it now does a lot more things than just volume management and RAID. One of the big features that everybody always asks for is snapshots. And then they also are now doing things like thin provisioning. Well, all of these different functions that we ask the storage controller to do take essentially CPU cycles, right? So we're asking a CPU to do more and more work. And so what happens is these CPUs have to get more powerful. In addition, there's an I/O path that goes between this controller and these disk shelves. The more disk shelves you have, the more I/O there is, the harder the CPU is going to work just doing volume management and RAID. So the combination is all of a sudden we're starting to see, for really the first time, storage controllers not be powerful enough to drive the number of drives that people need and to do the type of functions that they require. A great example is a new function that is, say, came out in the last 2 years or so, is automated tiering. And what that is, let's say we had a shelf of SSD and a shelf of HDD, and maybe a shelf of high capacity nearline HDDs. And we'd want to, what auto tiering does is automatically move data at a block level between these tiers, except those arrows I just drew aren't exactly accurate. Because really what happens is when data is being processed, it has to travel up to the CPU, be analyzed, and then put back down on the correct tier. So once again, we're asking that controller to work harder. So what's the impact of this is, as I said, the CPUs are now working harder and harder, and we need more and more power there. So when a system runs out of CPU power, what you essentially have to do is, what most people do is upgrade and buy a whole new system. They either put another new system here, or they just replace this one and put a new one in. So when you're doing a storage refresh, many times that's what's driving it. But this has now led to changes in the industry where controllers are going in different places. And there's probably two big initiatives that we see that impact that. First is the scale-out storage type of method, right? And so instead of one big controller, what we have at scale-out storage is a smaller node, and inside that node is a series of disk drives. So a node can also be essentially a server. So there'd be drives inside there, and then to add more power, we add another node and more disk drives, and then another node and more disk drives. And so essentially it scales out, right? The value, and then the volumes essentially are, so if you had a file, the file writes across all of these nodes, so all the processors that I have drawn there are involved in writing data, reading data, analyzing data, all those different functions that we were talking about. The other big initiative is either software-defined storage or hyperscale data centers, where essentially we've got a virtualization cluster and in that cluster we've got obviously VMs running. Then what we do is we put the storage intelligence that would normally have run on this scale-out environment as another VM, so we'll just call it a storage VM in each one of these. And so now, instead of in this environment where I would still have to connect into my hypervisor cluster, now it's all on one block, right? So that makes for a very interesting scale-out type of architecture as well, sort of a converged architecture. In the scale-out architecture, we're a little concerned that CPU performance actually becomes very wasted because all it's doing at that point is storage. So the combination is actually very powerful. So that, in short, is what a storage controller is. For more information, you can go to our site, storage-switzerland.com. There you'll find information on storage controllers and different types of storage architecture. I'm George Crump, lead analyst with Storage Switzerland. Thank you for tuning in today.